In the present video, we're going to present fractal curves developed in SMath Studio that present a meandering pattern. These meandering fractals will be generated using what is called a baseline and a motif. Let's get started by looking at the idea of the baseline and the motif. It is currently calculating because I have a lot of examples in there, so it should be done soon. Anyway, this is the program that produces the meandering curves. This program is available in Lauderdale's pages 38 to 45 because there are many examples, so it takes a few pages to present them. We use what is called a baseline. A baseline in the program will be defined by two vectors that are called A and B, and then vector C and D will define what is called the motif. For example, if I use this A and B and this C and D, the baseline, which is the blue curve in here, actually represents the coordinates x and y of the points that limit the baseline. The baseline in this case is a rectangle. And so we start at point 1, 1, which will be right in this corner, with a minus 1, 1, minus 1, minus 1, 1, minus 1, and back to 1, 1 to complete that baseline. The motif is represented by the vector C and D here, which represent coordinates x and y of the points 0, 0, which is this point right here. 0.4.2 is the little peak right here. 0.6 minus 0.2 is this one, and then back to 1, 0. What we're going to do is take that pattern and reproduce it in the different components of the baseline. That is done by this program, and you can download that program to try it on your own. This is the case that I was just presenting. The program actually uses many inputs. P is the level of development of the fractal. Let's look at some examples. This is the example that was presented to describe the baseline and the motif. And what you do of three levels of meandering, or three levels of fractal, sorry, of this model built up on the rectangular shape produces this island, this fractal island. If you use a sharper curves in here for the motif, you get this result. An island of fjords, if you use this model where one peak is sharper than the other one, you get this island of fjord for p equals 3. For p equals 4, it's even more dramatic. The island of fjords produces this nice symmetric shape, and if you look at the base of this, it's just like a Koch curve that is produced by using this motif that doesn't even reach to 1, 0. And all the examples so far have been presented on a rectangular baseline. On a rectangular baseline, using this little peak, produces this fantastic fractal where you get this peak penetrating here and then perpendicular peaks in every direction, producing what looks like an ice tray with cubes about to break in or break out of there. This is very similar to the first case. This one, I think it's probably the same. Yeah, it's the same. And this one, we have twisted the direction of the baseline, and it produces a similar figure to this one, just at a smaller size. This is just a line in the middle of the 0, 1 line, and it produces that pattern into the rectangle. Triangular baseline with a triangular shape peaks in there produces this nice pattern. This is another similar to case 5. And so far we have been using squares for the baseline, but you can use a straight line The blue line here is the baseline, and this model repeated for p equal 3 produces that result. For p equal 4, the same model produces a more detailed curve. And so these are some examples of those meandering curves using a baseline and a model or a motif, and you are able to produce some interesting shapes. We're going to present a couple of more videos on these with other resulting fractals. This is the end of this particular video.